Yes. Let me see. Okay. Can you see my screen now? Whiteboard. Is it okay?
Yes.
Okay, sounds good. Now we are gonna talk about the centroid. What is the centroid? Centroid is a kind of definition of the center of gravity. In Turkish, ağırlık merkezi. Okay. We are gonna do this. We are gonna calculate the centroid point for different geometries and how we can do it and how we can use it. Okay, we can calculate the centroid, but why we need centroid? We will see at the end of the lesson. Today, I will show an example about this, but the more examples will be next week, because next week we'll cover all the subjects we talked previously. Okay, so let's get started here. I'm gonna divide screen. The title is centroid. Okay. We are gonna calculate the centroid of two-dimensional shapes. Okay, not three-dimensional in this course. Centroid of 3D shapes. Shapes, or not shape, actually, it's about members. The member is better. Members. Okay, this problem is like, actually, maybe you can remember, we calculate the resultant force for the parallel forces. I guess 2 or 3 weeks ago. It might be in second week. This problem, the centroid problem, is like that. We are gonna do our calculations like we are calculating a resultant force of parallel forces. Okay, the logic is coming from there. So, as you know, when we have a member, let's say this book is a member, as you can see. Due to the gravity forces, it has a weight. So basically, we are looking for where is the centroid, where is the center of gravity point of the shape. Okay, when we look here, this book is a rectangle, so it's easy to find its centroid point. Yes, it's the midpoint. That's okay. But if we have complex shapes, complex members, we will, as an architect, I know that you don't like the rectangular shapes, basically. Do you want to design a rectangular building always? No, you're going to do different types, you're going to use different shapes in your design. So at the end of the day, we need to find out the centroid location of these different members or shapes. So I can explain this with a sketch. Let me see. Yes, here I'm gonna draw a sketch. This is X. Oh, X and Y axis. This is like a plane. So the vertical axis is Z axis. Okay, the vertical axis is Z axis. So here, let's say we have an arbitrary shaped member. This is not a rectangle. This is not a square, circle, whatever. This is an arbitrary shape. So we are looking for to find the centroid point of this member. So by the way, Let me write here X. This is Y. So we can say on this member, if we divide this member small pieces. By the way, I'd like to change this this member. Okay, I'm gonna draw a member like this again. Here we have a member. So this shape includes many small pieces like this. Okay, I'm just working on this small piece. It has a weight, right? Goes down in the vertical direction. Let's say its weight is WI. Okay, so the area is here, AI. So if I combine all these pieces weights, I'm gonna get the actual weight of this member. Okay, actual weight of this member. So let's say I have 1,000 pieces. So if I combine one by one all these weights, I'm gonna get the total weight of this member. So let's say the gravity point is this center of gravity point. So the total weight of the member acts on this point. So we will combine all these weights. That's okay. I'm gonna get the total weight, but where I'm gonna put this weight? I'm gonna put this weight to the center of gravity point. Let's say we call this G, or sometimes you can see CG, center of gravity point, this one. So in this coordinate system, it has coordinates like XG on the x-axis or YG on the y-axis. So yes, we know all the weight will act on the CG point or G point. That's okay. But where is this point? We are looking for this point today. Where is this point on this arbitrary shape? So if we let me change the color. For this member, this small member, yes, I'm just looking for to this square small member. It has a center point. This WI acts on this center point. So the center point's coordinate is XI here. It's like YI. Okay, this one. I. Let me clear this part. Okay, YI. This is better. So I will use this small member. Actually, I'm going to use a small member, and then I'm going to find the total members properties. Let's write the equations. Firstly, how we can calculate the total weight. If we write the sum of Z, the total Z forces, this means the total Z forces gives me the total weight. Basically, this W, the total weight, equals sum of, actually, I'm doing here, I'm writing the mathematical equations, what I explained at the beginning. Okay, WI. So I don't know how many pieces, 1,000, 10,000, 2, 3, 5. I don't know the number of pieces. But if I sum the weight of all these pieces, I'm gonna get the total weight, right? According to this equation here. Okay, we have the total weight at the moment. So what we are looking for? We are looking for xg and yg, because these coordinates gives us the location of the point G. Okay, xg, this one, I'm looking for this one and this one. But while while I'm doing this, I will use this the center coordinate of all these small members, small pieces. Let's write the total my here. It says, so here the weight is weight times xg. I'm gonna calculate the moment, because this is y, around y-axis. Okay, according to the y-axis. The total weight is this, and its distance to y is xg. xg times total weight. Total weight is this, total wi, right? So I've just calculate the moment around the y-axis. Then, okay, this is the left-hand side, total moment of the total weight. So I have many small members here. I don't know how many. So what I'm gonna do, I'm gonna calculate the moment of all these small members around y-axis. For example, for this member, wi times xi. Okay, wi, this is times xi. This is the moment, but this is the moment for one piece. I'm looking for all the pieces moment. So what I'm gonna do in the mathematical operation here, in algebraic operation, I'm gonna put here a summation. This means calculate the moment of all pieces around y-axis. Then sum all these numbers. Okay, so from here, I will get an equation. I'm just looking for the xg, remember. Xg is total vi times xi over total, this means this one, total vi. So calculate the total moment of each pieces divided to the total weight. That gives us xg. Okay, so it's same for the x-axis. Let's write the moment for the x-axis. That means we are going to calculate the moment around the x-axis here. So yg is the here, from here to here, the distance, times total weight again. Total weight is sum wi equals sum all the pieces moments according to x-axis, sorry, wi times yi. So if we do the calculation here, yg equals total vi times yi over total vi. Okay, when we look here, you can see only two equations. You don't have to memorize it. In the exam, I'm just trying to explain the logic, but I have to use the mathematical equations while I'm explaining all these concepts, I have to turn all these concepts to calculation. That's why I'm using these equations. You don't have to memorize them, but I'm gonna give you logic to do this. We will use this method. When you take a look at this equation, it looks very complicated. Okay, but it's not. It's really easy. At the end, I'm gonna give you a method, a table method. We will draw a table and fill all the blank boxes in that table. Then we will get these results. But to explain this, I have to write these equations. So at the end of the day, what is the centroid coordinates? As you can see here, xg and yg, these are our centroid coordinates. So here, the all members moments according to the axis divide total weight to get xg or yg. We will do examples in the next step. You're going to understand what we are doing here better. So if we have a member, now if we have a member, the thickness is here. Member thickness T and density, you know, we are using a material to make a member. So to calculate the weight actually, we need the density. You know what the density is? Yoğunluk. Okay. We need the density. The density here is gamma. If this member is a plate, okay, how we can write the weight and centroid coordinates? Let's write the weight first for each member. The weight is for a member. So the weight is volume times density, right? We know this from high school. Volume times density. Hacim çarpı yoğunluk. Volume times density. So if we write, for example, take a look at this small member here in the sketch. I did it orange. So if we write this equation, weight equation, what is it? The A1, sorry, AI, not A1, AI, area times thickness, T, right? What is this? This is the volume times density. This gives me weight of this small member. So if I change this these equations according to this weight here, let me write xg equals, so vi total vi is ai times t times density. Okay, this part is vi times xi. Xi. This is x. This is the top portion of the this division over what? Total weight. Total weight is what? Total weight is ai times t times. So here in this equation. Now, by the way, let's write this same equation for the YG total AI T over AI T gamma. So here in these two equations, what I did here, we have Wi in the XG equation. I've just converted it to the open form of weight given here. I didn't do any extra thing. So if we take a look here, we have some constant numbers. What are they? T and density. Okay, these are the constant numbers. So we can take these numbers out of the summation and then cancel them, basically. So at the end, what we are gonna get, total, the area times xi over total area. It's same for the y axis, ai times yi over total ai. So this is the equation for the surface members. If I have a surface member, if I have an area, I can calculate its center of gravity with using these equations. We are not, instead of to use weights here, we're going to use thicknesses. Okay, thicknesses. Sorry, areas. I'm sorry. A is the area. Because our assumption here is we have a constant thickness at each point and we have a constant density, which is gamma here. So at the end of the day, one of the variables is AI. So that's why we are using AI in this question, in this problem. So we know the XG and YG equations for surface members. If we have lines, members, what can we do? This is 2D member. If we have a one-dimensional member, by the way, do we have any questions, comments, anything for this page? I'm gonna open a new one. Okay. It's really difficult to explain these concepts with using Zoom. I'm just speaking to a black screen, so it's really difficult for me. But unfortunately, we are doing this. Yes, here, centroid of 1D members. Okay, if I give you a line like this is a, let's say this is a straight line. I can do it. I'm sorry. If we do this, can you tell me where is the center of gravity or centroid point? Is it easy for you?
Midpoint.
Yes, you're right, midpoint. If we know this total length, yes, we can define the midpoint is the G point for this member. But if we have a little bit complex shape, like let's draw the same X and Y axis. This is X, this is Y. If we have a member, let's say you have a wire, you did this shape like S. It's like a little bit S shape. So you can bend it like this shape. Can you tell me which point is the center point, centroid point? It's not easy. It's not easy. That's why we are gonna use the same methods we talked in the previous page here. We are gonna divide this member small pieces. For example, here, this member. Let's say length of this member is Li. Okay, Li. So what we have for this Li, we have the xi coordinate and the yi coordinate, the center point of this member. Okay, yi. We have two coordinates, but we are looking for the total shape's centroid point. Let's say it's this point. It might be out of the section. Okay, it might be here, but we don't know where it is. I don't know. So we're going to calculate this. Let's write the equation for this one. Xg, by the way, this is the Xg. This is the Yg. We are looking for these coordinates. Xg equals the total Li times Xi over total Li. The logic is same like the previous one. By the way, let me show you the previous page again. Here we are using area as a weight, area times distance over total area. And in the next page, for the one-dimensional members, lines or wires, we are using L, the length of the member. The equation is same, the logic is same. And Yg is here. Total Li times Yi over total Li. We will use this method. Okay. So this is the easiest way to calculate the centroid point of the members. Let me see here. Yes. Okay. Now we are talking about simple sections. If we have complex shapes, actually, what we are gonna do here, I'm gonna explain you to the table method, as I mentioned previously. It's the easiest way to calculate centroid. I'm using the same method, so it's really easy. Let's write here. Centroid of complex shapes. Okay. centroidal complex shapes. Okay, let's say we have a three-dimensional member. What was our equations? xi equals totally ai times, oh, I made a mistake here. xg, we are looking for xg, xi here. Total ai is for the yg equals total ai yi. By the way, this is the total. This is the total again. Over total ai. So this is the question. This is the equation. So how we can convert this calculation to a table? Let me draw you a table here. Number of the member. This is a template for you. Okay. Number of the member. Okay. Remember A1, A2, A3, whatever, how many numbers we have. Then calculate that numbers AI area. Then X coordinate of a small member, Y coordinate of a small member. Okay. Then right here, you can see here X AI times XI. Calculate AI XI for each row here, and AI times YI. Okay. Let me clear this part. It's a little bit long. For example, here, 1, 2, whatever. I don't know. This is the template table. So what we will get from this table? Here, you can see AI. We can get here total AI. And then here we have AI times XI, AI times XI. Here we go. Total AI times XI. And then here we have total AI times YI. So if I get in this table, I'm gonna get these three numbers at the end. So I will put all these numbers in these equations. Okay, that's it. To do these calculations in like a mathematical operation, it's a long story. It's not easy. You cannot understand if you do any mistake anywhere else. But this table method, is the easiest method to calculate the centroid. So actually, we are calculating these numbers from this table. So we are going to write all these unknowns for each member. Then we will get at the end 1, 2, 3, 3 important data from this table, and put these numbers in the equations in their place. Yes, you will get the X coordinate and Y coordinate, XG and YG. Here, by the way, in the, we are doing our sessions, courses in 2 sessions. In the first session, I'm going to completely do all the subject first. In the next session, I'm going to solve a few examples about this. We're going to see how we use this table in our calculations. It's really easy. We are just doing the multiplication and division. That's it. If you have a calculator, yes, you can do it easily. By the way, I'd like to remind you again, you need to get a calculator and you have to be familiar its functions. You have to be familiar how you can calculate the trigonometric operations. Okay, this is really important. If you come to a midterm exam without any knowledge, I can't help you because there are many different calculators. So their operations sometimes in different locations. It's not easy to find if you do it before you come to the exam. So it helps you. Okay. Yes. Here, what we see how to use the table. Okay. This is like a theory at the moment for you. In the next session, you're going to see how to use this. Okay, but we are just talking about the complex shapes. Let's calculate, or let's see another example. For example, here, if we have a shape like this. Okay, this is my shape, and there is a circle here. This is a void. Okay, my area is this. There is an opening here, circular opening. Okay, so I'm looking for the center of gravity point of this shape. Where is the center of gravity? CG point or G point. Okay, I need an axis system to write my equations here. Let's say this is X and here is Y, right? Okay, basically what we have here in our equations here, you can see we have different pieces here, different pieces. Okay, we can divide this shape different pieces. Let's do it. Here, if I cut the system from here, let's say this part is A1. Okay, this is the area 1, A1. And then the total area here, let's say I have a rectangle here. I have a total area. Okay, there is an opening on this area. Keep this in your mind. There is an opening, but take into account this total area, this total rectangle area. This part is, the total area is A2. Okay, A2 is the total area without any opening. Okay, but I know there's a circular opening over there. That's okay, no worries. Let's change color. I said green. Okay, here I have a circle, void. This area, this is A3. But if there is an opening like this, this is not in my area. In A2, to make our calculations easy, to calculate the area A2, I assume that it's like a rectangle, as you can see, but there's an opening there. So what I'm gonna do, I'm gonna consider this A3 with a minus sign because I don't have this area. Okay, I take into account that area totally in A2. Okay, but I know I don't have any circular area in this place. There is an opening here. So in A3, I take into account this area with a minus negative sign. Okay. If you do this, use the same table and calculate the total area. Now, any question regarding this shape or anything else? No. Okay. Okay, let's say you can calculate the centroid of one-dimensional shape easily. Let's say you can calculate it. But now we are gonna talk about a method to calculate the area of complex shapes. Let me show you what I mean. Pappus, can I show you? By the way, pause sharing. Can I'd like to show you something. What I'm talking about. I'm just trying to open my file. What's wrong here? Yes. Here. Yes. I'm gonna take into account this. Oop. Let's go back. Oh, I can't. By the way, okay. There's a problem here. Pulse sharing. New share. Can you see my screen now?
Yes, we can.
You can see the shapes and the text, right?
Yes.
Yeah.
Okay. Now what I'm trying to do. Let's say this is a little bit complex shape, but it's really easy. Let's say we have, can I draw the screen? Let me see. I guess I can do it. I have this line. Okay. I have this line. And the question is, if I rotate this line or this shape, this is not a line, this is a curved member. If I rotate this member around given axis here, there is an axis here at this point. Okay, here. For example, 19 degrees, 180 degrees, or 360 degrees. If I rotate this curve around this axis, I'm gonna get a surface, as you can see here. For example, if I rotate this 360 degrees, I'm gonna get this shape, this three-dimensional surface. Can you see the gray shaded area? Okay, the question is how I can calculate the area of this shape, this surface. Okay, I have a one-dimensional curve. It's like a wire. That's okay. But if I rotate this wire around an axis, I'm gonna get a surface. So what is the area of this surface? This is the question now. So you can use these methods where maybe you're gonna design an arbitrary shaped object in your professional life. So you may need its weight, you may need its area. That's why I'm explaining this method. So when I explain this method to you, it's not, maybe you can say, oh, when am I gonna use this one? But you have many points to use that, or you can draw this shape in a computer software and directly you can get the area. It's another way. You can choose that, but please understand to use these mathematical operations to calculate the area. Okay, this is for one-dimensional member. Okay, if I have a two-dimensional member, that means if I have a surface, when I rotate this surface around an axis, what am I get? What am I gonna get? Take a look here. Take a look here. This example. Here, as you can see, I have a arbitrary shape. When I rotate this shape around this axis, I'm gonna get a volume. Or let's have a look this ring here. There is an area. I have this area. Let's say this is a square. That's okay, no worries. If I rotate this square around this axis, I'm gonna get this here, this volume, because I'm rotating an area. When I rotate a wire or line, I'm gonna get area. If I rotate an area, I'm gonna get volume. Okay, so what is the volume of this new shape? That's the question. Okay, now I'm gonna show you how to calculate it. You don't have to rotate this totally the 360 degrees. For example, 45 degrees, 30 degrees, you can rotate it. For example, you have a ring here. Basically, I'm looking here in plan. Maybe you are looking for this volume, this part's volume. So you need this angle. Okay, this angle. You don't have to rotate always 360 degrees. Okay, it's total circle. That's okay, but you can rotate it in any angle. So I will explain how to calculate it. Firstly, I will explain how to calculate the area, as I mentioned here. Okay, then explain how to calculate volume. So let's go back, stop the share and share screen, whiteboard. Okay, we have a theory. What is it? What is it? Papus Gouldin. It's interesting. You don't have to know this name. Okay. The theory of the first theory. For the area calculation. The first theory is regarding the area calculation. So let me draw the sketch here. If I have a wire like this, okay, a wire like this. So this is the axis. I'd like to rotate this wire around this axis, any angle. I don't know the angle. Okay, I don't know the angle. So we have a equation. I'm gonna write it here, then explain it. Area here, angle times YG times L. Okay, by the way, the L is total length. Let me write it here. This is the total length, okay. Let's say the center of gravity is here. This is YG. Okay, Y angle is angle, the rotation angle. This is the rotation angle in radians, not degree, in radians, radyan cinsinden. Okay, the angle is that. YG. If we know the center of gravity, centroid point, I need the distance between this point G and the rotation axis. This is the distance. Distance between G and the rotation axis. Okay. If we find all these three unknowns, yes, we can calculate the area. If we put, for example, if I'd like to calculate the 360 degree rotation for this shape, what is my angle here? What do you think?
Can you repeat that again?
If I rotate this line or wire, whatever, 360 degrees around this axis, given axis, what is the angle here in this equation?
2 by 2 radians.
2 radians. What 2 what? Not 2 radians. 2
2 by
Yes, 2 pi. For example, for basically, let me write it. Degrees, you know, 2 pi. 2 pi. You may do it for 45 degrees. Pi over 4. Whatever. You can do it for 27 degrees. Find the radian, what it is. Okay, the angle is this. L is total length. Yes, you have to do it. You have to calculate it. The YG, firstly, calculate the centroid point, where it is, find that location, and then calculate the distance between the centroid point and the axis. That's it. This is the distance between these 2 points. If you multiply these numbers, you're gonna get the area. Okay, it's same for the, almost same for the second theory. The second theory is regarding the volume. Okay, let me write here. This second theory. Here I have an axis again, an arbitrary shape. So what I'm going to do, this is the area is area. This is the center. Let's say this is the center point, centroid point. This distance is YG. Okay, this is the axis. So if I'm looking for the volume when I rotate this member around the axis, the volume is the, again, angle times YG times, this time this is area. Okay, it's same. This is the rotation angle. This is the total area. So YG here is again the distance between the centroid and the rotation axis. These equations are really basic. If you think you don't have to memorize it, you have to find the rotation angle, the area, and the distance to the axis. That's it. Multiply these numbers, get the solution, get the volume. Okay, this is really easy. We have 10 minutes to go. Yes, I'm gonna give you 3 equations for the circular members, circular shapes. So you have to know these equations to make the further calculations. Let me write all these equations, 3 basic equations. Let me write these equations here. If we have the first one, if we have a line again, but a circular line. Okay. This is a half of circle. Okay. Half of a circle. Here, this is my X. Here. And this is X. This is Y. This is R, the radius. Okay. The center point Centroid point is this one. Okay, if I have a wires, half circular wire like this. This is not area, by the way. This is not an area. Okay, I'm gonna give you the area in the next point. But this is only wire. This is the center point. Okay, what is the YG? YG for this shape. What is the YG? YG is this. Because in the X direction here, this point is center point. There is no problem to find in the X direction, but the important one is to find it in the Y direction. Where is this location? So YG is here. Two times R, the radius, over pi. This is for a half circle wire. Let's have a look to half circle area. Now I'm gonna write the equation for area. Okay. Oops, sorry. Okay. Now we are talking about this area. I'm trying to shade this area to emphasize what we have. Okay. Now the radius is radius R. Again, center of gravity, center right point is here. The point G is here. And the question here is again YG. What is YG? If this is an half circle area, YG equals here 4 R over 3 pi. Okay. And if I write here, just a second. And okay. If I have this is the area. 1/3 of the total circle, as you can see. This is the only wire line. This is the 1/4 of 1/4 of, sorry, not 1/4 of a total circle area, as you can see. If we have these, what are the locations? Let's have a look. This point, the center right point is here. This is G. In two directions. And for here, 2R over P. here for our okay. As you can see here, we have 1/4 of a circular wire and circular area. When we look the centroid location in both directions, because here if we have a 1/4 of a total circle, we have to define the xg and yg. You can see the xg and yg dimensions in the first sketch, 2r over pi, and for the circular area, 1/4 of the circular area, you can see the centroid location for xg and yg is 4r over 3p. So take a look here. They are same as the half. You can see this and this is same. You can use you can keep this in your mind. If you know the half of a circular wire of area, you can do the 1/4 wire or area. You have to know these equations because in our examples we are going to see the half circles, we're going to see 1/4 circles, wires or area, whatever, I don't know. So you have to know these distances. So yes, today this is all I explain. There is nothing more to explain centroid, but in the next session we are going to see how to use all these data. We are going to do examples. Okay, we are going to see how to use this yg xg coordinates for half circle, 1/4 circle. So let's have a break first, half an hour. We are going to be here at 11:45. Okay, then we will do our examples. See you guys. Okay. Okay, here we go. I'm sorry. I'm working on a small table, so it's not easy to do. Yes, these things. Okay, I'm sorry. Share screen again. Okay, let's do it. The shape is like go.
Hocam ekranınız gözükmüyor ama.
Öyle mi? Bir dakika. Stop the share again. Share again. Şimdi geldi mi?
Şimdi de göremiyorum ama bende de bir
Hala
sorun
yok
olabilir.
hocam. Bende de yok.
Allah Allah. Görebilen var mı arkadaşlar şu anda?
We can see.
Bir saniye. Tekrar başlatalım. Şimdi nasıl arkadaşlar?
Still same.
Okay. Göremeyen arkadaşlar görüyor mu?
Hayır hocam.
Vallahi göremiyoruz.
Bir saniye arkadaşlar, niye böyle bir şey oluyor? Stop the share. Tekrar share ediyorum. Tamam, sıfırdan başladık. Tekrar ben bunu arkadaşlar şey yapacağım. Tekrar çizeceğim size. Sıkıntı değil. Şöyle yapalım. Okay, I'm gonna draw our question screen. Here we have a triangle. Okay, triangle, and here a lateral horizontal line. This goes down. And here. Okay, this is our shape. Let me draw the dimensions here. Here is 36. This point 36. Okay, and in vertical direction, what I have here, we have 40, and then here 36, 36, and left is 42. Okay, you can see our shape. As you can see, this area inside the black lines is our area. So we are looking for the centroid point of this member. So remember, to do this, we are going to use our table method. Okay, table method. What was the table components? First was AI, XI, YI, AI, XI, AI, YI. Okay, this is the number. Okay. Okay. In the first step, we are gonna fill these parts here, here, here. So if we can do each piece, these three, if we complete these three for each piece, then we can calculate these multiplications, okay, easily. You have your calculators, AI times XI, AI times YI, right here. That's it, fill the back. But firstly, we are gonna write this part. Okay. So we need to divide this complex shape to simple basic shapes. Okay, simple basic shapes. So here we go. For example, let me change the color pink. We can divide this part. Okay, we have a triangle here. And then how I solved the problem? Yes. Please follow the pink lines. Okay, pink break lines. And okay, I can accept this total area as a rectangle, totally, but I have a void here, that's okay. And this part, I have a square. This part is again an void. And then, you know, this part, actually, I'd like to clear this. Yes, let me give the numbers. Let's say this is 1. Here is 2. This is 2. And this is 3. Okay, total rectangle. Where is 4? 4 is this total area. This is 4. Sorry?
Can't we make it only 2 rectangular shapes?
Yes, but at the end of the day, we have curved lines here. Okay, you can do here, maybe smaller. For example, you can do a rectangle here or square.
Can I draw to show what I mean?
Yes.
Like, can we make it like this one and this one? And then we remove this two. Like it will
Yes,
be...
it's possible. It's another way. This is my selection. This method is my selection. You can do it. You can do it. You are going to remove that part. You are right. In these questions, there is no one solution, actually. You can divide it in different shapes, different basic shapes, actually. So that's okay. You are right. You can do that. So in my solution, I have these numbers. I solved all these questions previously. So that's why I have this solution. So here, this part, this total rectangle is 4. How can I write here? Let me write here 4. And this gap, the 1/4 circle is 5. And I have a half circle here, 6. Totally, we have 6 different area. Okay, let me write it here. 1, 2, 3, 4, 5, 6. Yes. And then what we need a reference. We need a reference. Let me clear this part, because what I suggest you, I generally take into account the most left part as an axis, but here there is a triangle here. If I select this part, there is a axis at the, there is a triangle at the left hand side, but no worries, we will consider it. Let's draw the axis here. For example, in here, this is my assumption. I will calculate xg and yg according to this axis. Okay. If you select another x, for example, you may put another x here in your calculation. So at the end of the day, you will get an xg and yg distance according to this axis. It depends on you, depends on the question, wherever you want. Here, this is the x-axis, sorry. Let me write this is x, this is y. So let's get started from first one. Here we have a triangle. In the first box, we have area. So we have all dimensions. This is a perpendicular triangle. So we can calculate the area. This times this over 2. Okay. So let me write the area here directly. I know what it is. Yes. So the second box says xi. Xi. What is xi? Xi is distance to y-axis, right? So this has a own centroid point. This distance is xi. So can you say what is this xi? Totally, this is 36. Totally, this is 36. Okay. Remember the 1/3 rule from the distributed loads. Okay. The total length is 36, and this part is 12. 12 and 24. So this xi is 24. But be careful. Please look to y-axis. Are we at the right hand side or left hand side? You can see here we are at the left hand side. Our dimension here is it takes minus, because we are in the negative side. So this will be negative, because if we make a continuous x-axis, the left side is negative, right hand side positive. To solve this problem, you can do it like minus 12, that's okay. Or you can put this y-axis to the end of this triangle here. At that time, every distance is in positive region. There is no problem. Okay, it depends on you. We will do examples. Now we are doing this calculation the first time. So we will find a easiest way for our calculations. Let me clear this part. Okay, 12. Let's write yi. What is it? So yi for this member is this distance. This part is totally 42. Let me calculate it. 42 over 3. Yes, here is 14 millimeter. This comes from 1/3 rule. Plus all the way down to this point. What is it? 36, 36, 40, 36, 36. Yes, 72 to 114. Yes, let me check again here. 126. Yes, this total distance is okay. We have just completed the first one. That's okay. This is the first member. Let's have a look at the second member. The second member is this part. Total area. So calculate the area. Can you see this distance times this one, 36? Yes. Multiply this number and this 36, get the area. I'm gonna have the area from my calculation. Yes. Okay, area is easy. Now the question is xi. The center point of this rectangle is midpoint, you know. Midpoint here. Let me change the color. No. This distance is 80. We're gonna write here 18. And we are looking for this total distance, yi. So totally this part 114 from here to here. These 2 points 114. The half of it is 57 plus 40. 40 is at this part. 40 totally 57 plus 40. It's 97. Okay, we've just completed the second one. Now we are looking for the third one. Third one is this, according to my pieces. It's again, by the way, remember we have a total circle, half circle here. We are gonna remove this part. Here, there is no opening. It's just a rectangle. Calculate the area, 40 times 72. It's easy. It's what? Calculate the area. And then xi and yi. Here we go. This is yi, this is xi. Xi is half of this total length is 36. That's okay. And half of this height. The total height is 40. Here is 20. Okay, we've just completed the third one. Now the fourth one. The fourth one is this. Oh, this area. We have a square here. You can see 36 by 36. Okay, we have a square, and then we are gonna remove the part 5. So 36 by 36 here, the area, total area, that's okay. The center point is here. Center point is here. Totally, let me see. We need this and this. 36 here and 18 here. Totally, it's 54, and then this is again center point. 40 plus 18. This part is 58. Okay, we just completed the part 4. Now we are gonna deal with the part 5. You can see this is an opening. You know, we are gonna remove this part. Okay, you can calculate the area. How you can calculate the area? You know the radius here. Calculate the total circle area and get the 1/4 of that area. It's easy. The area is, let me take here. But this area is negative. Okay, this area is negative because we are going to remove this area. Take the negative here. So now what we need the xi and yi for this 1/4 circular part. Let me clear first this blue lines. Oop. That's better. Okay, I'm gonna use, okay, we need this one and this one. So to do that, what we need here, remember the rules I explained at the end of the first session. If we know this part and this part, we can solve the problem. So they are equal to each other. What is this? 4r over 3p. 4r over 3p, right? R is here, 36. 4 times 36 over 3p. You can calculate this number. So it's here. And then let me calculate it. I have calculator here. I don't know that number. Over 3 times p. It's like 15. It's like this number. Okay. And total, what is total height here from this point to this point? 76 minus 15.28 gives us 60.72. Okay, and I've just calculated, you know, this 4r over 3p here, and also it's same for this point. So I've just calculated the vertical one. If we do in the horizontal direction, this total distance is from here to here 72 minus 15.28. Yes, this part is 56.72 here. Actually, we are not doing a special thing here. We are just trying to find the center point coordinates. That's it, according to given axis system. It's not a difficult calculation, actually. You can do that. But to get better understanding regarding this issue, you have to do a few examples by yourself. Okay, today I'm explaining this method. That's why I'm going so slowly. In the next week, while we are doing examples, I'm gonna go a little bit fast to solve a few more problems. Please try to find examples from Google and YouTube regarding this issue. Firstly, try to do it by yourself. If you do more practice, you can see these distance easily. Okay, we have the last piece, which is 6. It's actually an opening on my section. So which is 6, it's half of a circle. You can remember the rule for the half of section. It's same for the one fourth of the 1/4 of circle area actually. So this area, this point is important for us. Let's have a look this one. Firstly, calculate the area. The diameter is here, 36. Calculate the area. You can do it. Let me check the number directly. This is the number. But again, you have to watch out to this member. We are removing this area. That's why it should be minus. Okay, should be minus. Here you can see the minus, and here you can see the minus. We are removing these areas. Okay, but this one, this minus is coming from the axis system, because we are in the negative side. Okay, this comes from axis system. Okay, but these red ones are removing area. That's why we have to consider all these areas with a minus sign. Okay, then xi here, we are looking for this. We are looking for this. So to find this, we need this part. Again, you know, 4 times what is r here. The total is diameter. Be careful. Don't mix them each other. Diameter and radius. I know you know what they are, but while they are doing your calculations, generally people mix them each other. Okay, we will use r, radius. That's why this is totally 36. So half of it is 18 over 3p. Oh, sorry. 3p. So let me calculate it. Yes, this is 7.64. What was the total width? It was 36 minus 7.64. Let me check. Yes, it's correct. 28.36. Okay, let's have a look to yi for this half circle. Okay, till this point, we are looking for this. Totally, we have 76 till this point, 76 plus half of this height, because in this direction, it's at the middle point. 76 plus 18 is 94. This is 94. Now we have all numbers we need to go forward in this calculation. So basically, if we have all these numbers, get your calculators and do these calculations one by one. Multiply these numbers. Okay, I'm gonna write all these results here. Let me.
Professor,
Yes.
number 5, the area is, I calculated it is 1017, not 71.
Number 5. Where was it? This one.
Yes,
Let's
thank you. You switched the 7 and 1.
let's do it again together. Okay. This is the 1/3. Okay, firstly, and then what is the radius? Radius is 36, right? This is the area. I'm going with the diameter generally. Am I right? Yes. Let's do the calculation. P times 22 square over 16, right? 1017. Actually, my calculation looks right. This is Can you check your calculation one more time?
Yes, it is like that, but you rated 71. It's for that I get confused. Okay.
Ah, I'm sorry. Yes, you're right. I mixed them locations. You're right. I'm sorry. Yes, you're right. This is 17. I just write here 71. Thank you. Okay. We are gonna do all these calculations. Let me write numbers here with the signs. It's important. Okay, I'm gonna write numbers. Then yes. I can't see what I write here. Yes. Here, last one is minus. And okay, these are the numbers. Okay, I've just filled all these gaps and blind boxes here. Now, what we need this part here and here, the total ones, the total x summation. Let me write here. This box is summation box. The total area is, and total AI xi. And here, okay, if we have these numbers, the left part is really easy. The xg is you know, this part. 1 over. Okay, this one. It's centimeter, and YG is the total AI YI, which is this one. Yes. And the result is this. So we have XG and YG. XG and YG according to my X and Y axis. If you change the location of X and Y axis, you are gonna get different numbers. That doesn't mean you are doing wrong. You are calculating according to that axis. Okay, it depends on you. So here, the center of gravity is where, let me put a mark there. X, the half of is around this part, and 6. I guess it's around like this point. Here, from here to here, and from here to here is this one. I'm sorry, this markups on the sketch, because we are always writing on the same shape, but you get the point, I guess. We have just find the centroid location of this complex shape. This is the table method. This is the table method. If you do a few examples, you're gonna see you will be very fast regarding these problems. So we are not doing a complex calculation here. You have to be just careful what you are doing while you are calculating xi and yi. The other stuff is the constant number, I guess. Okay, you have to be careful, xi and yi. If you do them correct, the other stuff is, I guess, will be correct, because you will do just calculation. That's it. Okay, let's do an example for a wire. Let me do one more example. Oh. The shape is like half circle line, like this, and there's a lateral part. Okay, so the x is here. This is x, this is y. So dimensions, this part is 15. So by the way, our number is this, and this half circle. Okay, I used black everywhere, so sorry. Yes, here the height is here, 10 centimeters, and let me see. Yes, this part is 42. Okay, what we have here, what we have here. These are the given dimensions in the question. The question is, again, center of gravity point or centroid point. Here we have a half circle, a horizontal line, and a vertical line. This is not an area. This is a wire, one-dimensional shape. So we will apply the same method for this one. First one is number. The second one is Li, then Xi and Yi, and Li times Xi, Li times Yi. Okay. I have three members. The first part is half circle. The second part is the horizontal line. The third part is this vertical piece. 1, 2, 1, 2, 3. Okay. Here, if we have a look the half circle, okay, we can calculate the total perimeter of a circle, and then since we have a half circle, divide it to 2 and get the half circle perimeter length. Okay, I don't want to explain it. You can calculate the half circle perimeter easily. So according to given data, what we have, the diameter of this circle is 42. By the way, while we are doing these calculations, for example, area calculation or perimeter calculation, you're gonna use your calculators, and the number pi given in your calculator, don't use 3. Don't make any reduction at pi. Okay. Use your calculator, what it gives you. Push the button pi, that's it. Sometimes in exams or in their calculations, our friends using 3. No, I don't accept that. It was in high school. Okay, pi is pi, what it is. So, if you calculate this length, what is it? I did it. This one. So I need xi. Center of gravity point of this member is around this. It should be here. What is the xi for this one? The distance in x direction is 0 because I'm on the y-axis. Xi should be 0. But what is yi? Yi here. Yi is this. So firstly, we need to calculate this part and then sum it with 10. What was the rule for this part? 2r over p. So 2r 2 times what is r? 21 over pi. So this number is, let me see, 13.37. And we are not looking for this one. We are just looking for the total yi, distance with centroid point and this x-axis. So this is, because we have a 10 here. Okay. Let's have a look to second piece, the horizontal one. the total length is 15, right? It's basic. It's given in the question. 15. So what is xi? The center point is centroid, and xi is here. This one. Here is 21 plus 7.5. And this is 28.5. yi is basic from here to here. It's 10. And let's have a look the vertical member here. Its center point is this. Firstly, let's write its length. Its length is 10 centimeter, given in question. The yi is basic. Yi is basic. Y, you can see here, half of this total height, 5. And xi is a question. From here to here, 21 plus 15. So it's 36. Let me check. Yes. Okay. So if we write this table, multiply all these numbers to each other, and this is 0. Let me fill all these gaps here. And 150, and this and this. Okay. This is the last part. Summation. This one, and this one is important for us. The total length is coming from here. And total LAXI. And here. Okay, we have all these numbers now. And make the divisions. XG equals here. From the table. 8.66 centimeter. YG is over okay. You can see here XG and YG coordinates according to given axis system. Okay. These.
Hocam, can I ask something?
Yes, please.
Which length is L1?
L1. L1 is.
Yeah.
Let me show you this. Can you see blue line?
Yes, hocam, thank you.
This is L1. Let me write okay. Maybe that's better. L2 and L3. So these are XG and YG. Okay. Actually, this is our subject for today. Next week is the last session before the exam. That's why we are gonna do some calculations. I'm gonna solve a few examples regarding these centroid, and there are a few left from last week. You know, we didn't solve 2 questions last week. I'm gonna solve all these questions and more. If you have time, please take a look to your notes and try to understand what we did so far. So if you have any questions, come to class and ask your questions, and then I will solve problems. Because after that, let me see the dates again. Next week is 20. Yes, 20 November. The exam week will start 27 November. That week we will not have class. So 27 November and 4th of December, we don't have class. 4th of December, our midterm date. Please check this date from the announcements. I guess the school announced all these dates yesterday. Please check it. Maybe there will be some change. If there is, they will let me know. But so far, I didn't get any information. I guess date is okay, 4th of December. So please try to understand. If you do it until next week, when I show the examples, you can solve the problems with me. So if you have any trouble, you can ask there. If you don't solve, if you don't study, actually, I know you will do it last one day or last 2 days or last night before the exam. So this is not your core subject. That's why if you do this last night or last day, last 2 days, it's not easy to understand because you will be in stress. It's not easy to understand in stress these type of concepts. These are not difficult things. You have to watch out some special points. If you apply the rules I taught you, you can solve every problem. Please try to take your notes and we will solve a few examples next week. I guess you will be good in the exam. Okay. Thank you for your attendance today, guys. Take care of yourself. See you next week. Have a good weekend. Bye-bye.
Bye, teacher.